Honors Algebra. Mr. Lawrence here with your flip lesson. It's Monday, May 14th. I know DC is coming up quick. I'm excited. I know you are. We just got a little bit more to do. Remember, we're looking at a test on Thursday. All right, so we're going to start reviewing today. Tomorrow in class, we're going to do our RECA assessment. Actually, Wednesday in class, we're going to do our RECA assessment. And then we're going to have the test on Thursday. So these videos are going to be review. All right, and we're going to start first of all with domain and range. Okay, so first of all, let's take these two equations. These two equations right here that just magically appeared before you, and we are going to find the domain and range of each of these equations. All right, first off, remember I'm going to do my domain and I'm going to start with all real numbers. All right. Okay, all real numbers. And now I'm going to throw away every value that x cannot be. All real numbers such that my only restriction in this problem for x is that x cannot equal 0. And there's the domain of the first one. How did I get that? I got that on the restriction on x. Now the range. The range. Again, I'm going to start with all real numbers, right? Such that. Now when you get into Algebra 2, they're going to teach you a better way to find the range for the y values. But just for Algebra 1 purposes, here's what we're going to do. We're going to look at this equation and we're going to know that if this plus 1 wasn't here, let me hide it really quick. Okay, if I just had 1 over x, I would know that I would never be able to turn that equation into 0 because the numerator is 1, right? So I know that y would not be able to equal 0. Now, if I have the plus 1 on the end, I know that that shifts my horizontal asymptote up to y equals 1. Remember that? The horizontal asymptote of this guy would be y equals 1. So I know, therefore, that for my range, that's a restriction on y. Y cannot equal 1. And there you go. You've done domain and range. All right, let's try it for this one here. If you want to pause the video and try to do it yourself, that would be great. If you're still watching, I assume you want to see the answers. All right, so the domain, well, first of all, I'm going to factor this denominator, and I'm going to factor it as x plus 2 as a quantity and times x minus 2. And I picked x squared minus 4 on purpose. If you were in class on Monday, you know why I picked it. All right, so my restrictions on x, I'm going to say that the domain can include all real numbers such that x cannot equal plus or minus 2. Those are the only restrictions on x. My range will be all real numbers such that, and remember my horizontal asymptote, what number y cannot be? My horizontal asymptote, well, y equals -3, right? Y cannot be -3. There you go, domain and range. All right, now we're going to talk about something that you guys are a little bit weak on. Adding, subtracting, multiplying, and dividing rational expressions, all right? So I'm going to give you 4 different types of problems. Okay, so there's the first 2 problems, and notice they are addition and subtraction. Oops. They are an addition problem and a subtraction problem. In both of these problems, I need to find my LCD. I need to find my LCD. Now, I didn't see a lot of people doing this. Oh, no, what happened? All right, I need my LCD. Well, I know for a fact I need an x plus 5. That's that guy. I still need an x. A lot of you made that mistake. All right, I'm going to multiply each fraction by what it's missing from the LCD, but I'm going to do it both in the numerator and the denominator. On this side, I'm going to multiply by x plus 5. Not by plus 5, I'm multiplying. I can't just add 5 to that denominator. I have to use multiplication. So my LCD is x times the quantity of x plus 5. So when I do that, my fraction changes. The numerator of the first fraction becomes x. The numerator of the second fraction becomes 3x plus 15, and that'll be over the LCD. Now I'm not going to simplify anything here because of this addition sign. I am going to combine like terms. So I'm going to get 4x plus 15, and that's going to equal x times the quantity of x plus 5. I'm not going to forget to state my restrictions. X cannot equal 0 or -5. And there you go. Okay, if you need to go back and rewatch an old video on adding and subtracting, you go ahead and do that. All right, this one here, I need an LCD. But before I do that, I am going to factor this denominator. X plus 2 and x plus 3. I need two factors of 6 that add to get 5. Negative 6 plus 1 doesn't work because that's subtracting. Negative 6 plus 1 is a subtraction problem. It's 1 minus 6. That won't work. I need 2 plus 3. All right, my LCD is going to have a quantity of x plus 2 in it, and it's also going to have a quantity of x plus 3 in it. This first fraction I won't do anything to. It already has the LCD. I'm going to rewrite it as 6 over the LCD. X plus 2 as a quantity times x plus 3 as a quantity. All right, the second fraction is missing a quantity of x plus 3. X plus 3, x plus 3. Now before you distribute here, I've said this many times, I'm going to strongly recommend you change that to a plus and change the 2 to a negative so that you distribute a negative 2. So I'm going to get a negative 2x minus 6, and that'll be over my LCD. X plus 2 times the quantity of x plus 3. Okay, now this new problem. Looks like my 6's are going to cancel out, and I'm going to be left with a negative 2x over the LCD. X plus 2, x plus 3, and I'm going to go for my restrictions where x cannot equal negative 2 and negative 3, and there you go. That's the problem. I can't simplify this x with either of these x's because of the addition. I can't simplify that 2 with that 2 because of the addition. They won't simplify. That is as simple as it gets. All right, going to drop down here to multiplication. Multiplication, I don't need to get an LCD. I will factor. I'm going to factor each part. I'll factor this one here. I need two factors of 10 that add up to 7. They're both positive because of the Wendy's double stack. So it looks like it's going to be a 5 and a 2. I'll factor the denominator here. I'll pull out a GCF. All right. I'll factor this numerator here. I need two factors of 20 that subtract to get negative 1. I know I'm going to have two quantities beginning with an x. A negative 5 and a positive 4 would be two factors of 20 that could subtract to get negative 1. Negative 5 plus 4 or 4 minus 5. The denominator will be the difference of squares, which will factor like that. Now I'm ready to do some simplifying. And remember, I'm going to check 1, 2, 3, 4 different ways. Boom, boom. Boom, boom. Boom, boom. It looks like the only thing left in the numerator is an x plus 2. The only thing left in the denominator is a 3. Now I still need my restrictions before they simplified. So I know that x cannot be negative 4, cannot be a positive 5 or a negative 5. And there you go. All right. All right, last example, and then we're going to stop. And then tomorrow night's video will be a review of how to solve and how to graph. All right, so let's see here. I'm going to do some more factoring, and there's a difference of squares, and I'll get x plus 6 as a quantity times x minus 6. This one will factor here as quantity of x plus 6 times x plus 6. I'm going to multiply and flip. That'll become a 5. And then I'll factor this guy and put him in the denominator. He'll be 2 times the quantity of x minus 6. Now I'm ready to simplify. I know these minus 6's will cancel. I know that these x plus 6's will cancel. My problem is going to turn out to be the numerator will be 5. The denominator will be 2 times the quantity of x plus 6. For my restrictions, I know x cannot equal negative 6, positive 6, and I should really check this numerator because he used to be in the denominator, but since he's just a constant, yeah, he's just a constant right there, he won't affect my restrictions. And there you go. That's the whole problem. All right, we'll get a little practice with this in class tomorrow, and then on Wednesday we'll take that RECA test, and then on Thursday we'll take the Chapter 11 test, and then the grade book for this quarter will essentially be closed. All right, Mr. Lawrence signing off. Have a good night, everybody.